Hey there everybody. The purpose of this video is to get you some solutions to this little, it's like the extension quiz on the warm-up from yesterday. So it's the same graph as before. You had the scores of quizzes. You can get anywhere from a 0 to a 10, but sometimes they give you extra credit in Math 105, so you can get up to 11 or 12, and then the number of quizzes I've collected that had that many scores. So the first four, fairly straightforward. I'm gonna show you the math of how to do all four of them, and then we'll get the numbers real quick, and then we'll move to the back page. The first four were just practice, like I said. What percent of the quizzes turned in head scores of 12? Okay, so remember the total number that we counted were 499 quizzes altogether. That's important to know. That's your whole. The whole you're drawing from is the 499. So 100% of the quizzes would be all 499. How about 12? How many 12s were there? Well, if you look over here at the graph, there were 42 12s. So the chunk in number 1, or 1A, I guess, 1A, is 42 out of 499. 42 out of 499. And again, we'll get the decimal for that in a second, although it's going to be, we can approximate what it is. Next up, at least 8. Okay, at least 8. Let's think about that. At least 8. The English language is a pain in the butt, as I'm sure you know. So when you hear a word like at least, you hear the word least, and least means small. You know, most, least. But when you say at least this, that means that's the lowest you can go. You can't go any lower. So when you talk about grades of at least 8, you're talking about grades that are 8 or higher. 8 or higher. So if you think about all the ones that are 8 or higher, so there's 1B. Let's see. There's 29 8s. There's also 30 9s. There's the whopper 340 10s. There's 4 11s, and there are 42 12s, and that's still out of 499. That's still out of 499. Okay, so there you go. There you go. Like I said, we'll do that math in a second. I'm going to add all those numbers up and then divide it by 499. We'll take care of it. Okay, more than 8. So that I wanted to get you ready for this kind of wording. More than, or at least. Believe it or not, even though one has the word more and one has the word least, these are very similar. At least 8, you can actually say as 8 or more. But more than 8 means 9 or more. Because more than has a mathematical meaning and, you know, and a English meaning, more, greater than. So greater than 8. So let's see, 9 is, so basically it's this number minus that 29 in top. So it's that plus that plus that plus that. And like I said, we'll take care of that in a second as far as the numbers. Beautiful, beautiful, beautiful. And lastly, 5 or less, which actually, if you think about it, you can actually say that one differently. At most 5. 5 or less, at most 5. You can't go any higher than 5. So that's everything from 0 up to 5. So let's figure that one out. So that's 3 plus 2 plus 1 plus 1 plus 4 plus 5. All over 499. Okay, so let's actually get some numbers. Let's get some numbers in for these puppy dogs. Whoops, there's my lacrosse ball. All right, so let's get a calculator out. All right, 42 out of 499. So in class today, we were goofing around a little bit and talking about estimation. So I'm going to estimate each of these before we go. 42 out of 499, that's ballpark 40 out of 500. 40 out of 500. So if you think about that as 40 out of 500, I'll do the, you know what I'm going to do? I'm going to grab a piece of colored chalk. We'll go with pink because it's International Women's Day. This is about 40 out of 500. And then you can knock that fraction down to be out of 100 very easily, can't you? It's 8 out of 100. So that's going to be about 8%. Let's get you more precision than that, though. Let's get you as much precision as you need. What do we say? 42 out of 499. That puppy dog is, we're thinking, wow, we got no signal in here. Okay, we're not going to use the phone because apparently my office is sitting in a pit of no cell phone signal. 42 divided by 499 comes up at 8.4%. The actual answer, I'll do the actual answers in blue and we'll do the approximate answers in pink. So I approximated 8%, it's actually 8.4%. Not bad, not bad, not bad. Okay, next one down is 29 plus 30. We're gonna do some approximate math moving into exact math. 30 plus 30 is 60. That's 400. 450. 450 out of about 500. So this is about 450 out of 500. And if we do the same math we did above, like when we knocked that down to that, if we divide this puppy dog by 5 and divide that by 5, I get 9/10 or 90 hundredths. So I'm going to call that 90%. Let's see what it actually is with any kind of precision. That's going to be 29 plus 30 is 59, 399, 403, 445. Divide by 499, I get, oh, I typed too many numbers, hang on. I get 89%, if we round it off to the nearest whole percent. 89%, which is damn close to 90% that we approximate. See how we're approximating, getting close? We're gonna do that more in previous, or in sequential Math 58 classes. It's something I should have done more with you all this term, and just it's one of those things that came to me too late in the class. This C is very similar to B, except we're going to take essentially that 29 off. So if I look at what I did up here, I'm going to call that 30 just to make life easier for myself, and call that 420 out of 500. Now this one, I can't, the 420 divided by 5 in my head is going to be hard for me to do, so check this magicness out. 420 out of 500. Now watch what I do here. This is actually good. I think you're going to like this. Out of 500. I'm going to divide both of these by 10 to get it to be 42 out of 50. And then I can just double them both, and that gets it out of 100. So if I double this, it becomes 100. If I double that, it becomes 84. So I'm going to call that 84%. Let's see how close I get. Shoot, I should have added before. 370, 412, 416 divided by 499. 83%. What did I just say it was? 84. Yes, we came damn close. This is working out pretty sweetly so far as the approximations are going. We're off by no more than 1%. Last but not least down here, we're still going to make it out of 500 just because that's what we like to do. 3 plus 2 plus 1 is 6, 10, 16. I'm going to call that 20 just to make life easy. And then you can probably mentally do what I did up here. 20 out of 500, drop the zeros, make it 2 out of 50, which would be 4 out of 100. So I'm going to call that 4%. Let's see what it actually is. 6, 7, 11, 16. It comes out being 3.2%. I'll be damned. So those are pretty close. They are pretty close to what is actually going on in the exact calculations. Your estimates are getting pretty close, and that's nice because the 499 is so close to 500. You might as well just use it. But again, thank you for being patient with me this term while I'm trying to figure out the best way to teach it. Okay, so that's the first page of the quiz or the homework. Let's go to the back page now. And this was the one where we were playing around with some statistics here. I have 62 students enrolled in Math 105, yes. If we distribute the quizzes above evenly out across all 62, how many quizzes per student have been done? So we need a little bit of board, but not much. We don't need a lot left. Let's put it, we'll just go up here. We'll just go up here. Race a little corner out. Okay. So, and based on what we did in class today, this is actually going to make a lot of sense. I mean, you have all 499 quizzes. And then you have 62 students that you have to distribute them out to. So you've got 499 quizzes per 62 students. if you want to treat this like the proportions we've been doing, which is absolutely fine, that's totally fine. How many quizzes would there be per one student? How many quizzes would there be per one student? So if you think about our ABCs, it's going to be a 499 quizzes times one student over 62 students. Okay, and the students unit is going to cancel. So basically you're going to do 499 divided by 62, which is what I think most of you did anyway. And if you do 499 divided by 62, well, approximating that one's going to be a little bit trickier. Not really. Not really. Look, you know what? Let's do it. We're going to get the answer here in a second. Let's see how close we can get with an approximation. It's about, 500 quizzes over 60. Let's just make that math easy. Okay, 500 over 60. We can knock those down, and you're left with 50 over 6. Now, at this point, you can probably just do the math in your head, because it would be different if it was 6 over 50 as a percentage, but this is not a percentage, right? This is a number, a whole number of quizzes per student. Quizzes per student. That's the unit, quizzes. So what we end up with is 6 goes into 48 8 times, and 6 goes into 56 7 times. This is closer to 8, so I'm going to call this about 8. I'm going to call that about 8. About 8. Okay? So let's just get a number, 499 divided by 62, and 8.04. It's about equal to 8. Okay? It's about equal to 8. Okay. So that's that. That's that right there. Last question is, now if this is a rule I have in Math 105, so those of you that are going to take Math 105 with me, this is most likely going to be the same rule you're going to have too. I offer lots and lots of quizzes all term. I think I'm up to 25 this term. I think I offered just 6 more. Some ridiculous number. It ends up being something like 35 or 40 quizzes throughout the course of the term. Because I know how busy everybody is, so I offer tons of them. Your job is to do at least 10. Okay, so look at the last number you just calculated, 8. Does this mean that each student needs to do 2 more quizzes to reach that minimum? Why or why not? Write a sentence or 2 explaining. Okay? So based on what we talked about in class today, that should be able to help you answer this question. Does taking the 499 and dividing it across the 62 students, that's an average of 8 quizzes per student, which is what has happened in my classes. My classes, on average, have done 8 quizzes per student. But think about the lollipops in class today. 1 student had 5, 1 student had 1. On average, they had 3 each. But that doesn't mean they each have 3 each. That just means that's the average of what they have. So this average is 8 quizzes per student. 8 quizzes per student. Does that mean that each student has done 8 quizzes? No, it does not mean that at all. As a matter of fact, some of my students have been done for weeks. They're up in the 11 and 12 and 13 and 14 category. Some of my students do every quiz I offer them every week. And like I said, I've offered, well, that's not entirely true. That's not true. Nobody has done every quiz I've offered, but some of them have done the majority of them. And I've offered more than 8 already. I offered more than 8 in the first 3 weeks of class. So this does not mean that every student has to do 2 more. That's not. On average, yes, but not in reality. The average doesn't always represent exactly what's going on with a data set. It represents the sharing point of the data set, the point where things are shared out, like the lollipops in class today. That's what it represents. It doesn't represent what's actually going on. If an average represents what was actually going on, every data point in the data set would be exactly the same, which meant everybody in class would have done 8 quizzes, 8 quizzes, 8 quizzes, 8 quizzes. That's not what's going on here, necessarily. It could be what's going on here, but it doesn't mean that's what's going on here. So for example, just to make it simple, suppose the total number of quizzes turned in with 2 students was 16, okay, amongst 2 students. On average, they've done 8 quizzes per student. But what if one of the students has done 15 quizzes and one of the students has done 1? 15 plus 1 is 16. Does that mean they both still have to do 2? No, the one student's been done for a while. The other student has to do 9. But the average hides that, just like Amber said in class today. After Ryan and excuse me, Arlene did the lollipop experiment, Amber said the all those extremes get knocked off with the average. We focus on one number. And that was when I asked the question, is an average fair? Which is a tricky question because the word fair is what we have stat classes do, is to talk about that word. Okay, I think I've said enough today for the homework though. Hope that made sense. We'll see you next week for the rest of the M&M experiment. See ya.